Hi, we're here at the Atos Technology Days in Paris, and I'm here with Murli Mohan. He's responsible for the PLM department, if I say correctly,
right.
And you're the next expert in the digital twin.
Correct. That's right.
What's the real purpose and the goal of a digital twin?
I mean, we have been making products over several centuries now, right? I mean, you always conceptualize a product, you innovate in a product, you try the R&D part of it, you manufacture it, and then you just sell it or give it to someone
Correct.
who starts using it.
Correct.
Who knows how and where it is being used, whether it's being used or misused, whether there could be potential improvements which can be done on it. So where is the feedback loop to the rest of the organization, including the concept people, the R&D people, manufacturing people, what can be improved in the product. So what we are trying to achieve here is use the real-time data coming from the field services or real-time data coming from real use cases which are going on in the field and bring it back to the enterprise to use that knowledge and that information to improve future products and services. And we are trying to do that using the concept of digital twin, where you have a replica of the physical asset and a product in the form of digital, not just looks, but also in terms of functionalities, in terms of features and behavior, to feed back real-time data to the digital model so that we can simulate practically everything which can happen in the field.
And you were talking about some examples. Can you share one case?
Yeah, I mean, probably I'll just take two cases, very short.
Great, even better.
Exactly. So we're working on a case of wind turbine, for example, and wind turbine can be used in different circumstances, in different areas. It can be used in offshore, on-site. It can be used in very cold conditions. It can go through all kind of mess in terms of weather, temperature, humidity, and so on and so forth. But yet there is a challenge for the wind, the producer or let's call it the power companies to predict how much of power will be produced in the next 1 week or 1 month, because we all need a certain predictable power available at our home. And the OEM needs how the wind turbine is functioning in a certain place. So to be able to close that loop, we are trying to bring the data back, and we are trying to make a simple use case where availability of wind turbine is being calculated with a 360-degree view of the data in terms of how much failures have happened in the last 5 years, how much of inventory has been used of a certain part, how has the weather condition changed over the last 20 years. Can I predict the weather pattern? So that he has a very, very solid model with which we can do artificial intelligence and machine learning to be able to predict much better failures, predict much better power output, and also availability of turbine. So that's one use case. The second one is about automotive. Yes. If you have, for example, a model of a car, and the OEM has to come out with a new platform for 2025 model. How does he know what percentage of his existing cars can be reused in the 2025 model? Because he doesn't want to engineer the entire product.
Too expensive.
Too expensive.
Yeah.
So how does he get a predictable way how can he get a predictable way to estimate the life and the performance of each one of those components? And that's where we are able to use digital twin for.
Murli, thanks a lot for sharing all your knowledge. Thank you for watching from Atos, here from Paris, from Atos Technology Days.
Thank you so much.
Thank you.
Pleasure.
Enjoy this video? Don't forget to like, subscribe, share, and get notifications of my new video.